how is it possible that random chance can be a critical element in data analysis and machine learning? Well, how about a weather report? There's a chance of rain. Is it going to rain or not? There's some randomness there. There's a 40% chance of snow. Or imagine if you're in a community that is subject to tornadoes. So, tornado warning. Will it happen or not? There are too many random elements to know for certain. Randomness is common. Well, how about if we're in a kind of a random forest here? And look at those. Maybe there are two kinds of trees, but everyone is different. They started out maybe with the same genes from the same big tree, but through random elements, they all went in different directions. So how can random be anything but confusing? Well, let's just see how we can find a path through this randomness to see how it's used in machine learning. So imagine that you and two friends are dropped off in the middle of the night in a hilly, forested, remote area, and your task is to find your way to safety. A good algorithm might be to walk downhill. Maybe you'll find a stream, follow that maybe to a lake, maybe there are cabins there and people. Maybe you'll find a road going through a valley. So let's see what happens when our three people wander downhill. Well, if you're one of the lucky green guys, your path, regardless of which way you start, you realize, oh, I'm going uphill, I'm going to turn around and go downhill. So that initial random direction doesn't matter. You use that to orient yourself properly. Then, if you keep on going downhill, you keep heading down and you get to a minimum, which is actually used as a way of reducing the error rate in machine learning algorithms. So this is called a gradient descent algorithm to minimize the error, to get to the final low part. But how about if you're the red guy? And you go downhill, but you get to a local minimum where it's just kind of a dip, but you can't see that there's any real lower minimum, and you think, okay, I'm at the lowest point, now what do I do? Wow. So how about if you want to get data from this crowd? Are there too many people? They're coming and going. How do you keep track of it? Well, for decades, statisticians have known that, hey, no problem. You take a random sample. Why random? Because it eliminates bias. Because if you got them, a whole bunch of them from one collection, they might be from all one fraternity or who knows what. Okay. So ideas here are that random elements really are essential in data analysis and machine learning. For emergent phenomena like weather and biological growth are examples of where random elements have huge impact. But the future is always chancy, right? And a machine learning prediction is about the future, so it can't be accurate all the time. We take a random sample. That's a big idea, which you'll see over and over again in machine learning. The idea of a random seed for where we begin, and there's even an algorithm called the random forest algorithm. So a little bit about random chance in machine learning and data analysis.